How you doing today? Just finished cooking for the week and wanted to talk on chapter four of volume one in the Sacramento State issues. Um, this is the eighth edition, and today we're going to talk about clarifiers. So when we talk about clarifiers, we can talk about the primary clarifiers. That's before, after grit removal. There are circular clarifiers and they allow the solids to settle out. Any suspended solids to settle out to the bottom or to float, or there can be secondary clarifiers. And those are after your trickling filter, your RBC activation, sludge activation. So you can have clarifiers at the beginning and you can have clarifiers at the end of the process. And the whole point is just for sedimentation and flotation to happen, where we're using nature's way, gravity, of really doing some cost saving measures and trying to separate the solids out because with the solids is attached BOD. Usually in the bigger plants, let's say you like Atlanta, Cincinnati, those are the plants that you're going to have primary clarification. It's economy of scale. It's it's probably the most efficient way to remove large amounts of total suspended solids. Our friends from the water, and maybe you're a water operator also, we use clarifiers in the lime stabilization to separate um, the lime to settle to the bottom. So clarifiers are used uh, almost in every plant, not always, but in almost every plant. Sedimentation and flotation, chapter 4, page 194. Clarifiers are designed to physically remove those solids that will settle easily to the bottom or float to the top. The most important function of a primary clarifier is to remove as much settable and floatable material as possible. Removal of organic settable solids is normally important because of the high demand for oxygen, BOD, in receiving waters or substantial biological treatment units in the treatment plant. So on page 195, you can see a clarifier. So the influent comes into the middle, goes up, as you can see on the bottom, and then is dispersed. And the solids will settle. And you can see that in that picture. That's the gray is the solids. They are settling to the bottom. And the clear is the light blue. And so the clear liquid will settle and will go over weirs. Usually you can see up at the top right hand corner effluent weirs. And so the water will go over the weirs. You will have some scum that will pop and you'll see a scum baffle there and a skimmer arm. So a circular clarifier usually has a twisting motion where that sludge collector mechanism will go around in a circle. And what it's doing is it's pushing the sludge to the center hopper. And you can see sludge withdrawal uh, pipe. That's the basic version of clarifiers. Usually in the secondary clarifier, we like to keep 1 to 3 feet. Sludge blanket in there is recommended. The reason why we don't keep too much sludge, have 5, 6, 7, 8 feet, is because you could have sludge gasification, where the sludge will then pop, or denitrification. Perhaps if you're not getting good enough denitrification in your plant, and so it's paramount that we keep that sludge to about 1 to 3 feet. You can check that with a sludge judge, and I'm pretty sure there's a picture in your book where an operator once a day will check, or maybe once a shift will check. On page 197, it says suppose the water velocity It is horizontal at a rate 2 feet per minute, and the tank is 200 feet long. It will take 100 minutes to travel through the tank. So when we're talking about uh, surface area, detention times, your engineer is hopefully figured out what kind of detention time you have um, in your for your system, and hopefully you're not hydraulically overcoming that. On page 198, we want to look at temperature because temperature affects everything. I'm sure when you go out to run, possibly you move a little slower when you run. Well, the same way with temperature. When we have temperature, we need to remember that in general, as water increases, the settling particles of the particles increases. As the temperature decreases, so does the settling rate. We have aerobic digesters where I work, and as the temperature gets colder, we'll shut the blowers off, and we're trying to get the digesters, the aerobic digesters, to settle down. And in the wintertime, it becomes really hard for that physical separation to happen so that we can get the clear water off. And that's the same thing, whether it be an aerobic digester, we call that decanting, or a clarifier. We're wanting the solids to separate. It says when the temperature is higher, it is easier for the particulates to push the water molecules out of the way and the particles settle faster. When the temperature is lower, the water has more resistance to be moved, which slows the settling rate of the particulates. Temperature affects it. And as an operator, maybe you work in a cold environment. Maybe you have a dome over uh, your tanks, but there's not a lot we can do, unfortunately. But be cognizant that our clarifiers maybe will not settle as well uh, when it's colder. At a package plant, if you're having trouble and you're like, yes, I have a package plant, a small little plant for a school or a park or something like that, you can try adding a polymer, possibly. Check with your regulator, but you could add a polymer to get that to settle so that you don't billow over your clarifier wall and send mixed liquor downstream to your other treatment. Short circuiting. As water enters the settling tank, it's possible for it to short circuit. So if we have a tank and the water takes a straight path through that and does not use the side area, but takes the path of least resistance, you're going to short circuit. You're not going to use all of your tank. And so that's why in the uh, water and wastewater industry, we have baffles and walls in tanks so that that water uses the whole tank for detention time and treatment. And then also, so sides of the tank will not get septic. Detention time. As wastewater passes through the tank at varying flows, the tank size should be provided for any given volume to remain in the tank long enough to allow the sufficient settling time for solid particles. Hopefully, your um, engineered it right. We want to talk about weir loading rate. So that's just the linear feet of the weir that goes around the clarifier, and then surface. Surface loading rate. This rate is expressed in terms of gallons per square foot of tank surface area. There's several math problems uh, on the side for figuring out your surface area and your surface loading rate and your uh, loading rate. Safety. Once again, we need to just watch our atmospheric hazards. Um, when we're cleaning it, make sure our ladder, sometimes we have to get down in the clarifier, make sure that we are tied off. Um, it Obviously, we sludge judge those in the wintertime, in the spring, and it could be raining. So always making sure that you avoid falls. It says on preventing drowning on 206, keep a U.S. Coast Guard approved personal flotation device and lifelines handy. Most clarifiers are circular on page 207, but you can have rectangular clarifiers. On 208 is a good picture of of primary clarifier or a circular clarifier. You can see that the drive motor is in the middle, and that drive motor uses brushes that do contact so that as it spins around, it's not just twisting wires. I never, as an operator, when we first started, I didn't really understand what was going on there. But that drive motor has brushes that make contact. So as that motor spins, it's making contact all the way down. Rectangular clarifiers, I have seen them. I've seen them in primary treatment, but they have flights on the bottom that collect the sludge because it is rectangular. Page 210, in the very top, it says clarifiers that do not produce an acceptable effluent usually fail due to operators' errors, equipment failures, or excessive hydraulic loading. Be sure that the accumulated settled solids are removed from the bottom of the clarifier before septicity and gasification take place. Also, make sure that surface floatable fog are continuous and regularly skimmed, removed from the water surface to prevent floatables from reaching downstream secondary treatment. Let's talk about sludge and scum. One of your test questions is what is bulking? And bulking is due to Pseudomonas bacteria and is common in secondary clarifiers. It's clouds of billowing sludge that occur throughout the secondary clarifier and sludge thickeners when the sludge does not settle properly. In the activated sludge process, bulking is usually caused by Pseudomonas bacteria or bound water. You want to know that definition because I guarantee if you take your test, they're going to ask you about bulking sludge and what is that due to. At the bottom of page 211, I want to highlight the last sentence. It says conditions that may affect sludge concentration are specific gravity, size, shape of particles, and temperature of wastewater and turbulence of tank. 213, there's not much an operator can do to maintain, this is the third paragraph down on 213, under excessive hydraulic loading. If storm flow infiltration is a frequent problem, sealing of the sanitary sewers or the use of flow equalization basin may improve the quality of clarifier effluent. Once again, you have a huge storm, maybe you're a combined sewer system, and you have massive amount of rainwater coming into your plant. There's not a lot you can do. Hopefully you have EQ basin that can dampen that flow. Hopefully you have reserve storage. But as an operator, like for me, I take care of the collection system also. So anytime we can decrease inflow and infiltration out in the collection system, the less rainwater we have. So I know in the municipality that I work in, we line the sewers. So older clay sewers, we will go in and physically put a plastic lining in there. It's like a mold that they put in there, and then they cut the taps out. Our goal as water and wastewater operators is not to treat rainwater. At least uh, most of us, that's our goal. I think maybe at some point, some plants will have that as an added goal. But the water that's coming in from cracks in the clay pipe, uh, manhole lids that are not properly sealed. We want to do all we can do to decrease I&I. Perhaps there are neighbors' gutters that are tied in. I know I went out and we did smoke testing, and so we would put smoke down the manhole and see where the smoke would come out, and that would tell us where illegal sewers were actually tied into, or illegal downspouts were tied into. Be careful when you do it because someone's on call the fire department if their house does have illegal tap. On page 223, you can see our final effluent, our raw. Although primary clarifiers are designed to remove TSS, they will also remove some biological oxygen demand because of the particulates that are large enough to be captured in the clarifier, organic in nature. So you're going to probably get more removal of BOD and organics in your primary than obviously your secondary. And that's a good picture of the final effluent. You know, we come in raw and we want it to leave that way. We want it to be cleaner than the creek that we are discharging to, or body of water, whatever that may be, lake. On page 227, it just talks about flow equalization. Maybe you have a package plant. The primary disadvantage of flow equalization is the amount of space it requires. The primary benefit is the improvement of effluent quality because of the ability to operate the downstream processes in the wastewater plant as a constant flow with less variables and loading. You know, we don't want shock loads. We don't want to, let's say our plant is designed for 1,000 gallons per minute. Okay. Well, we don't want to put 2,000 gallons per minute through. If you're going to do that, you'll wash out your aeration, mixed liquor. Your clarifiers are not going to settle well. So if we can take that 2,000, let's say it's coming into the plant, and that's what the importance of the flow measurement. But if it's coming in at 2,000 gallons per minute, if we can send 500 or 1,000 to equalization tank or a holding tank, process the 1,000, and then bring it back slower, maybe when the rainfall stops or later in the night. A lot of bedroom communities, the flow will be the greatest during the morning when everybody gets up and is showering. Also, one of the benefits of equalization is it takes maybe your municipality or governmental agency, maybe you have factories, and so flow equalization kind of dilutes that the solids, and so instead of a slug load of a high BOD from possibly like a potato chip factory, it'll dilute that, and so it sends it in at a diluted concentration. Well, that's it for today. It's a quick chapter. I hope you're enjoying it. Like I said, I'm trying to get better every time I make a video. Thank you for watching.